Hello everyone, this is video 2-10 to be watched Thursday, October 13th, and the corresponding homework is pages 15 and 16 all. And as I said in the last video, we're going to have 4 rules total for taking the derivative. The power rule, which is the first one we learned, the product rule, which was the last video, and today we're doing the quotient rule. So here I clipped from a book a description of the quotient rule. So right here is the formula that we're going to use, and so we have f of x over g of x, so the quotient of two functions. If we want to differentiate that or take the derivative of it, then we have to use this formula here. Notice the numerator looks exactly like the product rule except with a minus instead of a plus, and then in the denominator you're going to square the denominator of the original function that you're taking the derivative of. And then down here is another description of the quotient rule, but with Leibniz notation. Now guys, the thing about the quotient rule is it is more complicated than the product rule, and you don't want to use it if you don't have to. So I'm going to ask you a couple questions at the beginning of each example, which is going to help you decide whether or not you in fact need the quotient rule, because if you don't need it, you don't want to use it. So here's the question that's going to help you decide that. Is the denominator a monomial? So down here is our function. The denominator is 3x plus 4. That is not a monomial, that is a binomial. So monomials would look something like, so if you don't know, ax to the n. Something like that, just a single term polynomial. And no, this is a binomial that has 2 terms, so the answer is no. If the answer to this is no, then you do need the quotient rule. So therefore we need the quotient rule. And you could just circle need if you want. All right, so now that I know I need the quotient rule, I'm going to set it up. So I'm going to set it up with my brackets. So I'll have 2 sets of brackets, a minus between them, and then in my denominator just 1 set of brackets. So just like the product rule, prime on the first one, prime on the last one up here, and then in the denominator we're squaring. And then you just take the 2 functions that you have a quotient of and you put them in the brackets. So f is always the top one and g is always the bottom one. So yeah, and actually guys, let's backtrack a little bit. So up here let's write f over g in brackets prime. This will be f prime g minus fg prime all over g squared. Okay, so there is the quotient rule. Alright, so I'm going to put f in the first bracket, 4x squared minus 2, g in the next, 3x plus 4, and then I just repeat that. So 4x squared minus 2, 3x plus 4, and always the denominator, the original denominator in the denominator. Guys, we're not going to simplify this. So I'm about to state our final answer, so I'm just going to write f prime of x equals, so the derivative of this one is 8x, so just 8x, parentheses, just bring down g. Okay, so that bracket doesn't have a prime on it, so we're not taking the derivative, we just bring down the function. Minus, and now this one, the bracket I'm taking the derivative of is this one here. The derivative of that is just 3. So I'm going to move that out in front. I'm going to like switch the order there. And then I just bring down 4x squared minus 2 all over 3x plus 4 squared. Okay, so there's that, guys. And so I was just looking over my notes from the workshop I went to over the summer, and I wrote to myself that I want to always repeat this to you guys. Don't simplify unless it helps you, okay? We are at the end of the problem, so simplifying, it wouldn't help us except maybe to make us feel better if it would look a little nicer, but you can stop right there, guys. So don't simplify unless it helps you. Like if you're in the middle of a problem, simplifying totally could make things a lot easier. Otherwise, don't bother. Okay, so next example. Is the denominator a monomial? Again, no, that's another binomial. So therefore we need the quotient rule. So I'm going to set it up with the brackets. So I'm going to have two sets of brackets, a minus between them, and the denominator one set of brackets, which I'm going to square, and then prime on the first, prime on the last. So in this case, we've got f, our numerator function, is just 1. G, our denominator function, is w to the third minus 1. And then I'm just going to repeat that over here. So 1, w to the third minus 1, and then w to the third minus 1 in the denominator. Okay, so I'm going to take the derivative now. So we're going to have f prime of w equals, the derivative of a constant is 0. So actually, guys, this entire thing, we're going to have 0 times this one. This whole thing is going to be 0. All right, so you can just jump right to that if you want. Just in case it's not clear to some people, I'm going to write it out for now. In the future, I would skip this step. Minus 1 times the derivative of this is 3w squared all over w to the third minus 1 squared. Okay, now I just said don't simplify unless it helps you, but if it's 0 times something, guys, I'm going to write this again because this is just 0 right here. And in fact, I would normally skip, I would normally not even do this step here as soon as I recognize a term's going to be 0. So that's negative 3w squared over w to the third minus 1 squared. Okay, so there's that derivative. Now, example 3, is the denominator a monomial? I actually have two denominators here, and they are both monomials. So I probably should have said, are the denominators monomials? So I'm going to say yes. Therefore, we don't need the quotient rule. Guys, if the denominator is a monomial, then you could just, break stuff up and then use the power rule. And again, you do not want to use the quotient rule if you don't have to. So I'm going to rewrite this as 10x to the negative fourth plus 3x to the negative second. And now this is a sum of terms of the form ax to the n. So I could use the power rule. So f prime of x is negative 40x to the negative fifth minus 6x to the negative third. Okay, guys. So the videos have been long lately, but that one wasn't too bad. That was only 8 minutes. The homework, remember, is pages 15 and 16 all. Okay, see you soon.